Right, so for today's lesson, we are going to discuss how to use the concept of transformation of graph, right, to sketch maybe the details of the graph, all right, and also to make sure that how we can actually explain or describe the transformation if the question wants you to explain it, right? Okay, so let's start with some very basic graph first, basic curve. Okay, so the basic curve you learned it in previous video already, but this is just a revision. Okay, so first we are having the linear function. So for linear function, we are having it as straight line. Okay, so generally you are having general form is ax plus by plus c equals to 0. And then if you write in the intercept form, this is what you have as intercept form, and this is a gradient form. Alright, so gradient form will be y equals to mx plus c. Okay, then next we are having the basic graph of quadratic function, and we call it parabola the shape. Okay, general form is ax squared plus bx plus c. So usually when we want to do transformation, right, we will start with the basic function here first. So to me, the basic function of quadratic is x squared. Okay, then the other things are all the other types of quadratic equation or maybe quadratic expression. Generally, they are the transformation of this basic shape. All right. Okay, so for quadratic, you need to know the completing square form. To me, this is very important. Once you have the completing square form ready, then you can also find out the turning point from the completing square form, and also the discriminant can help you to decide whether how many x-intercept you have or how many roots you have for the quadratic equation. Okay, then the third one is cubic. So for cubic equation, generally this is a basic one, equals to x power 3. Then others will be a power 3, ax power 3 plus bx squared plus cx plus d. So this kind of graph, we actually didn't learn how to sketch it. So we basically learn the basic one only. All right, and also some simple transformation. All right, so again, we try to sketch the x cube. If let's say you want to use a transformation, right, this is the basic shape that we look at. All right, okay, the next one, we are having the absolute value. Absolute value means that modulus function. So modulus function, if you write it out, it can be a piecewise function, and we will learn this in A2 syllabus. It will be part of our A2 syllabus chapter 1. All right, so for now, you just need to know that when you want to sketch a graph, it looks like a V shape. Okay, then after that, graph of rectangular hyperbola, when you are having a reciprocal function, right, generally you are having the graph like this, we call it as rectangular hyperbola. Right, so in our syllabus, right, for us, the general form is c squared, y equals to c squared over x. But for me, usually when I teach, I will just tell students why I'm having 1 over x. Okay, the shape is exactly the same, right? And then you should know that we are having asymptote under the part rectangular hyperbola or reciprocal function, right? Then next one, what is the meaning of graph of positive square root? So square root means that okay, when you're having y equals to square root x, this is the basic shape of the graph. Okay, so the function is not defined when x smaller than 0, which means there's no graph here. On the part where x smaller than 0, you only have the value x greater than 0, then you have the graph. Right? Okay, so all these are the basic function that you should know. But to me, I think all these are quite important because they are all quite basic, and then all the functions here are included in our syllabus. So it will be good if let's say you know the basic shape of the graph. Okay, so let's start to the main point here. Okay, so first we talk about the transformation of graph. Okay, so for transformation of graph, the first type of transformation that we have is translation. Translation means that you are moving your graph either go up, go down, go to the left, go to the right. So we call it as translation. All right, so for translation of graph, we are having two types. The first one is vertical translation. Another one is horizontal translation. Okay, and then when you have the vertical translation, the plus a, you plus a number or minus a number outside the function, and you want to write in a bracket form, it will become 0 and a. 0 means a, x didn't move anything, any coordinate, but y coordinate, you move it a unit up. If a is positive, that means you translate the function up a units. If let's say a is smaller than 0, that means you translate the function down a units. The keyword translate must be included in your solution if let's say they ask you to explain the transformation. Okay, you can use the word translate or you can use the word shift. Okay, or move. All right. Okay, then when you're having horizontal translation, okay, it say you are having a plus A here. Okay, and then when you write it in the horizontal form, it will be A and 0. Okay, so if A greater than 0, that means A is positive, then you are going to move it A units to the left. Okay, when A is smaller than 0, then you are going to translate the function A units to the right. Okay, so if let's say you feel a bit confusing here, then usually I will tell students, maybe you can separate it into two parts like this. One is x plus A, and then this one is fx minus A. Okay, so when you write it out, it will become negative A and 0. And when you write out this one, it will become A and 0. Okay, so for this case, first case is you are moving the graph. You shift how many units? Okay, so you shift A units to the left. Okay, and then this one, we shift A units to the right. Okay, because when we simplify everything in one formula, a lot of students they will feel very confusing. Like, the greater and 0 and smaller and 0, and also the sign over here makes them feel very confusing. So I think it will be good if let's say you can separate it into two cases here, so that you understand it better. All right, so when you're having x plus A or negative A, that means you are shift A units to the left because you're having negative value here. Okay, but when they try to put in under this part, you see A smaller than 0 means A is negative. Okay, so you are going to translate the function right A units. Oh, sorry. So the A smaller than 0 in our case here, they are talking about this. This A is smaller than 0. Okay, all right. So again, as what I said, if you feel very confusing now, then maybe you can remember it by using these steps, these two. All right, so that you won't feel confused. Okay. All right. So this is what we have for translation of graph. Okay. So have a look for example 1. Example 19. Okay. So for example 19, this is the basic graph that we have. Fx equals to x squared. So for fx equals to x squared, the basic graph is a U shape. It will look something like this. Okay. All right. So maybe I draw it better. Wait. Okay. So maybe this is what I have. Okay. So I'm having y equals to x squared. Okay. When they're talking about y equals to fx plus 4. So when you're having plus 4 outside the basic function, that means that you are going to shift your graph 4 units up. So when you want to shift your graph 4 units up, it is still a U shape. And then you already move up 4 units. So that means this smallest value will be a 4. Because originally it is 0. So you can label it as y equals to x squared plus 4. Okay, then how about for part number 2? So for part number 2, they want you to they want minus 4, okay, outside the basic function, outside the function, minus 4. So you're going to move your graph 4 units down. So if you want to move your graph 4 units down, so it will become something like this. It is still a U shape, but this smallest value become negative 4 already. Okay, so what's the value here? What are the x-intercept here? So you can let y equals to 0, and you try to get the value negative 2 and 2. So all this value, right, although they didn't request us to label everything in the graph, but you can try to label it because it might be very helpful when they sometimes are very helpful when they want to answer some question, okay, by using the graph. So it will be good if let's say you can try to label everything here. Okay, so you're having x squared minus 4 in this case. Okay, so if let's say in the exam they are asking you what is the range for these two graphs here, so the range for these two graphs, okay, assume that what they want you to sketch is for the domain, x can be any real number. All right, so if x can be any real number, when you are looking for the range, so for this case, what is the range here? So the range here will be y greater equal to 4. Okay, then how about for this? So for this one, you'll see that the small value is negative 4, and the graph keeps on going up, and therefore when you are looking for the range here, it will be y greater equals to negative. Okay, so this is how we sketch a graph when you're having the translation. They are quite basic to me. So I think you should be able to know how to draw it, and also please make sure that you know how to look for the range, okay, from the graph. All right, so let's continue to example 20. Okay, so for example 20, we take it out from a specimen paper of year 2020. Okay, so they give you a curve here, and then they want you to translate it by 2, 0. So they want you to find and simplify the equation of the translated curve. All right, so if you look at this one, what does it mean? It means that you need to actually substitute the function of f with minus 2 inside. Correct or not? Like what the example that I showed you above. Okay, so x minus a, when you write out, it becomes a0. All right, so the same thing happened here. That means when you're having 2 and 0, right? When you want to translate it, become the function type, so it will become f and then x minus 2. So what is the meaning of fx minus 2? It means, okay, so it means that for your new function or your new curve, all the x must be substituted with x minus 2. Okay, so I'm having this one, x minus 2 squared, minus 3, and then x minus 2, and plus 4. Okay, so if I try to expand everything, x squared minus 4x plus 4. Okay, so when you try to expand everything, you'll get another new equation here. Okay, so what is this new equation with this one? So generally, this is your original function for x, and then this is actually the function f minus 2 after you do the translation. Okay, all right, so this is how we solve this kind of question, and they want to simplify the equation of the translated curve. So this is how we do. You have to know that what happened to your function. All right, so for this case, you actually minus 2 inside the basic function. So that means you have to substitute all the value of x by using x minus 2. Okay, so this is a type of question that they might ask you in the exam. All right, so hopefully you know how to do it. Okay, so next one. Let us continue with example 21. Okay, so when we talk about example 21, what do we have here? Okay, so first they want you to express, okay, 6 squared, x squared plus 6x plus 4 in this form. All right, so again, to me, right, this is quite basic, right? So please do it on your own. Your answer should be x plus 3 squared minus 5. Okay, then for the second part, they want to describe fully the sequence of transformations that map fx to gx. Okay, so when they try to map fx to gx, this is your fx, this is your g. All right, and then what I want you to know is that the gx here, actually just now you already find out the completing square for gx. Can you see that or not? This is gx actually. Okay, so they ask you to convert it into a completing square form. So this completing square form is very useful actually. All right, because when they ask you to find the transformation from fx to gx, generally you need this completing square form, okay, as a reference. All right, when you want to write the answer. Okay, so let's start with fx. What is fx? X squared. Okay, and I want to change it become this pattern. All right, so now you have to go, maybe you can do it step by step. After x squared, what do you have? You should have x plus 3 squared first. Okay, and then after that, only you change it become x plus 3 squared minus 5. All right, so when you try to look at this, what's the translation here from x squared to x plus 3? So you actually translate this one 3, you translate 3 units to the left or right? To the left, right? This one is you translate it 3 units to, okay, and then for this one, from here, when you want to go to this part, you will actually translate it again 5 units down. Okay, so they want you to describe fully, so that means you need to write out in a proper way. Okay, so this is just for your reference to roughly know, okay, how you actually apply the transformation to fx become gx. Okay, so when you want to write the proper steps, you can write it like this. You can write fx is translated or shifted also can, is translated 3 units to the left. Okay, and also what happened? 5 units down. Okay, so what I want to tell you is the keyword all are very important. The first one is you have to show them that it is translated. Okay, so or maybe shifted also can. The second thing is you must have the unit with the direction. So 3 units to the left and also 5 units down. Okay, so this is how we describe fully the sequence of transformation. All right, but usually I will just try to write out all the symbol here to help me to understand better first. Okay, all right, then now if no problem, then let us continue to part number 3. On the same set of axes, they want you to sketch a graph for y equals to gx and also y equals to hx. Okay, so before we sketch the graph, gx you already know how to sketch it roughly. Okay, so maybe for me, for now, I will want to completely square the hx first before I can draw it out. Okay, so to do the transformation, to understand the transformation, maybe I want to do the completing square first. So I will have x squared plus 8x plus 4 square minus 4 square plus 11. And I should have x plus 4 square plus 3. I did a careless mistake, sorry. So it should be negative 4 square is 16 plus negative 16 plus 11, you will have negative 5. Okay, so this is my completely square form of hx. All right, and now they want you to sketch a graph on the same axis. So when you want to sketch a graph, what should you do? Okay, so for this part, you are having x plus 3 square minus 5. So that means you should know that your... Okay, so for this one, the minimum point will be at negative 5. X coordinate will be negative 3. Okay, and then if your x is equals to 0, then you should have a 4. So that means maybe this is negative 3, and maybe this is 5, negative 5. This is negative 3, let's say. Okay. And then this is a U shape. Okay, and then because just now I told you, if you want, you can substitute the value of, how to say, the value of x equals to 0 and try to find the y-intercept. So if you look at it, you'll see that your y-intercept will be something like this. This is the 4. Okay, because 0 is 3 square is a 9, 9 minus 5 is a 4. If you didn't draw or plot this value, is okay also, because they actually didn't ask you to draw until so detailed. Okay, then this is my gx. You have to label it clearly. Purple color one is gx. Okay, so now if I want to label or maybe sketch hx. So where is hx? The minimum point will be at negative 4 and negative 5. So assume that this is negative 4 and this is negative 5. So this is the minimum point that I have. All right, so you can try to sketch it also. It is still a U shape and the shape should be the similar as what we have. Okay, and they should be parallel to each other also, right? So what do we have here? It should be, this is hx. All right, so you can see that you actually shift 1 unit to the left, okay, from gx to get the hx. All right, okay, so is what they are asking on part number 4. So part number 4, they ask you to describe fully the transformation that maps gx to hx. So from the graph, you can see very clearly, okay, you are moving gx unit to the left, okay, to get the hx, right? So you can describe it like this, hx. Maybe you can write gx is shifted. Okay, so you can write this hx is shifted 1 unit to the left from Gx. Or maybe you can write that Gx is shifted 1 unit to the left, and to get the Hx also can. Alright, as long as the meaning of the question is there, then it should be okay. Alright. Okay, so this is what we have for the translation of the graph. That means you move it either up, down, left, right. So besides drawing the graph, you also need to know how to describe all the function and all the transformation correctly. Okay. All right. So let's continue to part number 3. Okay, part number 2. So we talk about the reflection. Reflection means that you reflect your graph up, down, or left, right. Okay, so when you're having the reflection is in x-axis, that means you are multiplying negative outside the basic function. When you are having reflection in y-axis, that means that you multiply the negative inside the basic function. Okay, and then I will want to on another one. There's a reflection at the line x equals to a. So when you have the reflection at the line x equals to a, that means y is equals to the function of negative x minus a. So this one actually is the same. This one is actually x equals to 0. Y-axis means x equals to 0. So when you write out the equation, it should be y equals to f negative x minus 0. Okay, but we usually didn't write x equals to 0, 1, right? So we will denote it as y-axis now. Alright, so the concept generally is the same. Just that they simplify become reflection in y-axis. But I do realize that we are having some question that they might want you to do the reflection at the line x equals to a. So I think it will be better if I adding it here. Okay? Alright, so please make sure that you take note on this part. Alright, let's continue to example 22. Okay, so for example 22, you are having fx equals to x squared and also gx equals to x power 3. They want to sketch a following graph. Alright, so I will just straight away, you can pause the video first and then you try to sketch a graph first, because there's no discussion about this. Alright, so I will straight away show you the final answer only, because it's very simple. Alright, so for part A, negative fx, so my graph will look something like this. Okay, so this is part A, y equals to negative fx. Alright, then for part B. Okay, so for part B, what do we have is this one. Okay, they want you to have y equals to f negative x. So when you have the negative inside the basic function, right, you reflect it left, right. So when you reflect it left and right, generally the pattern is still the same. Okay, then for part C. So what do we have it here for part C? Okay, so for part C, we will have this. Okay, so we are having y equals to negative gx. Okay, you reflect it up, down. So up, down, and down, you compare it with the original function up, down. So it will become the graph like this. Then you're having g negative x, which will give you the same graph also. So y equals to g negative x. Alright, so this is what you have for the basic reflection. You should know about the reflection here. All these are very simple and straightforward. Okay. Alright, so now, okay, so for example 23, because they actually put in the example that multiply the 3 inside, so I will discuss this later after we discuss the stretching. Okay. Alright, so now proceed further for example 24. Okay, so they give you two functions here and they ask you to describe fully the transformation that maps fx to gx. So from fx to gx, they're asking you how actually can you get, okay, or what kind of transformation you carry out from fx to change it become gx. Okay, so for this kind of question again, you will see that the pattern are almost the same. So you try to look for the difference between these two functions. If you look at the x here, plus 3 is still plus 3, though, right? The value is still the same. X become negative x. So this is the difference. And then you see overall the pattern is still the same, but the 2x here become negative 2x. That means you should suspect that you are having actually x and you change it become negative x. Understand what I said or not? Which means, okay, so which means you are actually trying to put the x become negative x into the function f. Okay, so you're having negative x plus 3, and then you're having 2 multiplied with negative x minus 1 square, and then you should have 3 minus x, negative 2x minus 1 square. And this equation is exactly the gx. Alright, so then is you just change the x become negative x. So this part is a bit, not to say tricky, but you need to identify the process yourself, because actually the question didn't give you any hint. Okay, so you can try to just compare what's the difference between the fx and gx, what is the difference in the pattern, or what kind of difference you can find out from these two functions. Then you try to get the idea from that. Okay, so now you already know that you are changing the x become negative x, which means you multiply the negative inside the basic function, right? So what kind of transformation you are having? So you're having the reflection in y-axis. Left-right reflection. Okay, all right, so this is what you have. So again, the keyword here will be reflection, and in what line? Is it in y-axis or is it in x-axis and so on? So all the keyword, please make sure that you write it out clearly. Okay, all right, so this is what we have so far for the transformation of graph. So we covered two ideas so far. The first one is translation, and also the second one is reflection. All right, so for the next video, we will continue with the stretching of graph. Okay, so we'll continue this in the next video.